Okay, so any observations? Yes, Roshane?
So for the graph of G po, this function scales f by a factor of 2, causing it to stretch vertically. This means the graph of G will have the same shape as f, but will extend further from the x-axis.
Okay, very good. So let's try. What is the original graph? X cubed minus 4x. So f of x plus x cubed. By the way, you can use any letter, no? X cubed minus 4x. And then g of x, what if you multiply this by 2? X cubed minus 4x. So again, earlier, if we multiply the output, remember the output is x cubed minus 4x. If you multiply it by 2, you are multiplying the y value. So the point here, for example, the point here, the y value is 3. So if you multiply that by 2, it becomes 6, right? And every point. So if you multiply the output, you're actually stretching the graph, no? Vertically, no? Away from, sabi nga ni, was it Roshane? Sabi niya, it moves away from the x-axis. No? And of course, if you multiply it by a smaller number, like h of x equals, say, of course, if you multiply by 3, it will become times 3. But if you multiply it by 0.5, for example, so h of x, for example, is x cubed minus 4x, then it also, of course, it shrinks, no, vertically by a factor of 0.5, no. Okay, so meaning multiplying the outputs by a number greater than 1 will stretch the graph vertically. So the graph looks steeper, no? As you can see, the slope steeper. But multiplying the outputs by a number between 0 and 1 shrink the graph vertically. The graph will look flatter, you know. It's closer to the x-axis. So for example, 1/3 f of x. And this is more pronounced when you use, for example, sine and cosine functions. So it's more obvious when you use this graph. Okay. So that is the third, and this one is the last one. Another 5 minutes.